Whenever you hang a chain from two poles, it always makes this same general shape. But what even is this shape? It kinda looks like a parabola, but also not really. What is the shape? More importantly, how do we even figure out what the shape is? We can go back to looking at our curve, but before that, we need to make some assumptions about it. First, the chain is perfectly flexible, so it has no weird tensions pulling along it. Next, it has uniform density, so gravity affects it the same everywhere. It's in static equilibrium, so there's no external forces. The chain length is fixed, so it doesn't stretch. The chain is smooth, so we can differentiate it, and we can perfectly model the chain with a function y of x. Now we can zoom in on a tiny part of the curve, and it kinda looks like a line here, but we can focus on a tiny segment of it. The endpoint on the left is pulled by the rest of the chain, and so is the right endpoint of the segment. There's also the weight of this tiny segment of the chain. Because there's no external forces horizontally, the horizontal tension must be constant. If you look at the tension of the entire segment, the slope of the chain must be equal to the slope of the curve, since the chain is the only thing pulling itself, and that means it's the derivative. We can rearrange and differentiate this relationship for later. After that, we define some constant lambda to be equal to the weight of the chain per unit arc length. That means if we multiply the arc length of the segment of the curve by lambda, then the entire left-hand side is essentially just the weight. Looking at the force diagram, the only thing canceling out weight is the difference in the vertical tension, so the weight is also the difference in vertical tension. After that, we move dx over to the left side, and the left-hand side is the derivative of the vertical tension. So now, we can go back to our original expression for this derivative and substitute it in. We can move the horizontal tension over, and because this entire ratio is a constant, we can just set it equal to a, whatever a is. Y double prime is the derivative of y prime, so we can rewrite it as such, and then we can separate the variables and integrate both sides. We get an arc cinch on the left side, so we can bring that over to the right. And then we can rewrite y prime as the derivative of y. That means we can separate our variables again and integrate again. After that, we flip our definition of a, and then we can set x and y with some offset so that the constants disappear. The shape is called a catenary, and it's the general form of a hanging chain. And we can plot it on a graph and we can vary a. As we vary a, the curve moves up and stretches out. Since a is the ratio of the tension to the weight per length, we're basically controlling how tight the chain is. And that's about it. Thank you for watching.